Assalamu alaikum everyone. This is Ghazal, a student of MSc Final in Organic Chemistry from University of Karachi. My presentation topic is gravimetric analysis of nickel 2 in ores and alloys. First of all, I would like to thank Professor Dr. Nasreen Fatma, Dr. Shahjan Nisar, Dr. Sadaf Iqbal and Dr. Asad Khan Tanoli for giving me this opportunity to portray my talent. Now moving towards the introduction. Overview of gravimetric analysis. Gravimetric analysis is one of the most accurate analytical method available. It is concerned with the determination of a substance by the process of weighing. The element or radical to be determined is converted into a stable compound of definite composition and the mass of the compound is determined accurately. From this, the mass of element or radical is calculated. The gravimetric analysis involves precipitation, filtration, washing of the precipitate, drying, ignition and weighing of the precipitate. Let's talk about ores and alloys. What is ore? Ore is natural rock or sediment that contains one or more valuable minerals or is extracted from the earth through mining and treated or refined, often via smelting, to extract the valuable metals or minerals, whereas alloy is a mixture of two or more elements where at least one element is a metal. After ore and alloy, we will discuss about occurrence of nickel. Nickel is an element, atomic number 28, between cobalt and copper. Nickel has been known for a long time as an element or as a mixture with other metals, but it was only isolated as an element in 1751 by Axel Friedrich Kronstedt in Sweden. Nickel occurs widely throughout the Earth's crust and is thought to make up about 10% of its core. Normally, nickel is found in conjunction with iron in laterite minerals such as nickel ferrous limonite or magmatic sulfides such as pentlandite. Those are huge reserves found near Sudbury, Ontario in Canada. Example of some nickel ores are pentlandite and garnierite. Now a brief talk about nickel alloy. Nickel alloys are used extensively because of their corrosion resistance, high temperature strength and their special magnetic and thermal expansion properties. Some nickel alloys are given below. Analysis of nickel. The separation of nickel from other ions in a sample is a good example of specificity in quantitative analysis. The amount of nickel can be determined by precipitation with dimethyl glyoxime from a slightly ammoniacal solution. Nickel identification with dimethyl glyoxime. Nickel containing solution give a red color with a diluted solution of dimethyl glyoxime. Nickel to salt form a specific red color complex with dimethyl glyoxime. This reaction is used in analytical chemistry as a nickel identification tool. Nickel 2 forms a precipitate with the organic compound dimethyl glyoxime. The formation of the red chelate occurs quantitatively in a solution in which the pH is buffered in the range of 5 to 9. The chelation reaction that occurs is illustrated below. When nickel 2 reacts with 2 moles of dimethyl glyoxime in the presence of ammonia to form nickel dimethyl glyoxime complex. Although the loss of one proton occurs from one oxime group on each of the 2 molecules of dimethyl glyoxime, the chelation reaction occurs due to donation of the electron pairs on the 4 nitrogen atoms, not by electron on the oxygen atoms. The reaction is performed in a solution buffered by either an ammonia or citrate buffer to prevent the pH of the solution from falling below 5. If the pH does become too low, the equilibrium of the above reaction favors the formation of nickel 2 ion, causing the dissolution of nickel dimethyl glyoxime complex back into the mother liquor. Now chemical and reagents. The nickel is precipitated as nickel dimethyl glyoxime by adding an alcoholic solution of dimethyl glyoxime and then adding slightly excess of aqueous ammonia solution, and these are the chemical for required. Now we will discuss the procedure of this analysis. 0.5 gram of unknown nickel ore sample was accurately weighed and completely transferred to a 100 ml volumetric flask acidified with 1 to 2 ml of HCl solution and made up the volume of the flask with distilled water. Nickel 2, being a transition metal salt, has a green color due to partially filled d orbital. Now 50 ml of nickel solution was transferred to a beaker and then 2 ml of 1% dimethyl glyoxime solution was added in it. Dimethyl glyoxime is not soluble in water, that's why we need alcohol to dissolve. The solution was heated at 80 degrees centigrade and allowed it to cool. After cooling, ammonium hydroxide was added in it. Ammonium hydroxide was added continuously until red color precipitate was obtained, and this red precipitate is the nickel dimethyl glyoxime. The precipitate were filtered through a G4-sintered glass crucible and then washed with cold water. Wash continuously until the precipitate were free from chloride. Used acidic silver nitrate. The G4-sintered glass crucible along with wet precipitate of nickel dimethyl glyoxime complex was kept in oven at 110 degrees centigrade. After dried and cooled at room temperature in desiccator, the weighed the G4-sintered glass crucible along with precipitate of nickel dimethyl glyoxime complex. Now let's move the observation. Weight of sample is 0.543 gram per 100 ml. Weight of empty G4-sintered glass crucible is 50.6042 gram. Weight of precipitate of nickel dimethyl complex is 0.0853 gram. Weight of empty G4-sintered glass crucible plus weight of precipitate of nickel dimethyl glyoxime complex is 50.6895 gram. Molar mass of nickel dimethyl glyoxime complex is 288.91 gram per mole and molar mass of nickel is 58.69 gram per mole. Now this is how we do the calculation. Weight of precipitate of nickel DMG complex is equal to the sum of the weight of G4-sintered glass crucible and weight of precipitate of nickel DMG complex. From this, we subtract the weight of empty G4-sintered glass crucible. By putting all these values, we get the weight of precipitate of nickel dimethyl glyoxime complex, which is 0.0853 gram. Now to get the weight of nickel, we apply unitary method. 288.91 gram of nickel dimethyl glyoxime complex contain 58.69 gram of nickel. 0.0853 gram of nickel dimethyl glyoxime complex contain 58.69 into 0.0853 upon 288.91 gram of nickel. 0.0853 gram of nickel dimethyl glyoxime complex contain 0.0173 gram of nickel, so the weight of nickel is 0.0173 gram. Now we will find the percentage of nickel. The formula of percentage of nickel is weight of nickel upon weight of sample into 100. By putting all these values, we get the percentage of the nickel, which is 3.2%. At the end, the result of this analysis, the percentage of nickel 2 in ore is found to be 3.2%.